Welcome. I heartily welcome you to Math Simplified by HM. Today's lesson is the foundational Pythagoras theorem. We are moving beyond simple calculations to explore its geometric origin through a formal proof of similar triangles. If you find this helpful, please like, share it with your colleagues and subscribe with the bell icon turned on. Make sure you have your notebook ready. Remember, you can pause at any time and let's get started. Pythagoras Theorem. The theorem statement: in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides. As per Pythagoras theorem, in a right angle triangle, the sum of the squares of two sides of a right angle triangle is equal to the square of the hypotenuse. Remember, the hypotenuse is always the longest side, positioned directly opposite to the right angle. To prove this, we begin with our given information. Given right angle triangle ABC, where angle ABC is equal to 90 degree. Our goal is to prove mathematically AC square is equal to AB square plus BC square. To make this proof possible, we perform one crucial construction. Draw perpendicular segment BD to hypotenuse EC such that ADC. Perpendicular BD to hypotenuse AC where D lies between A and C. Step 1 of proof. In the right angle triangle ABC, segment BD is perpendicular to hypotenuse AC as per our construction. According to the property of similarity and right angle triangles, the two smaller triangles formed by the altitude are similar to the original triangle and to each other. Therefore, triangle ABC is similar to triangle ADB is similar to triangle BDC. Now step 2, from our established similarity, we take the first pair triangle ABC and triangle ADB. As these two triangles are similar, the corresponding sides of the similar triangles are proportional. AB upon AD is equal to AC upon AB. By cross multiplying the terms, we get AB square is equal to AD into AC. Name this as equation 1. Step 3. Similarly, we take the second pair of similar triangles, triangle ABC, similar triangle BDC. Again, we know that their corresponding sides are also proportional. So, BC upon DC is equal to AC upon BC. By cross multiplying the terms, we get BC square is equal to BC into AC, equation 2. Now final conclusion, adding equation 1 and equation 2, we get AB square plus BC square is equal to AD into AC plus DC into AC. Now taking AC as a common factor, we get AB square plus BC square is equal to AC into bracket AD plus DC. Since ADC form a straight line segment, we get AD plus BC is equal to AC. Therefore, AB square plus BC square is equal to AC into AC. Therefore, AC square is equal to AB square plus BC square. We have proved the theorem statement. That wraps up our proof. As Pythagoras said, wisdom truly learned will never be forgotten. You know how a foundational tool for all your future studies. Thank you for joining me today. Please like, share this with your well-wishers and subscribe with the bell icon turned on. So you never miss a lesson, enjoy the great time and keep practicing.